Hello, hello. Here we are with our 3.3 notes. We are going to be solving absolute value equations. So we have learned our transformations. We have applied those transformations to the absolute value graph. And so now we're actually going to solve those absolute value equations. So in the first example, we are actually going to solve the absolute value equation by graphing. So in part A, we see the absolute value of x minus 2 is equal to 3. So you need to think of both sides of this equation as two graphs. So we really have y is equal to absolute value of x minus 2 and y is equal to 3. Well, y is equal to 3 is going to be a horizontal line going through that value of 3, okay? And then we should know by now that the absolute value of x minus 2 is the absolute value graph shifted 2 units to the right. So I'm starting here at my vertex. I have not stretched or compressed it. I've only shifted it to the right 2 units. So then there is my absolute value graph. And so I can clearly see that I have two solutions to this absolute value equation. And that is when x is equal to -1 and when x is equal to 2, 3, 4, 5. Okay. So in this case, we had two solutions. Think about how many solutions we could have when we have an absolute value equaling a number. So when we have an absolute value graph and some horizontal line, we could have this instant where the line goes through 2 points of the absolute value graph. So that means two solutions. But we could also have where the horizontal line is going through the vertex point of our absolute value graph, meaning we only have one solution. We could also have no solutions at all, meaning that horizontal line doesn't even cross through our absolute value graph. So just keep that in mind that we could have no solution, one solution, or two solutions. Okay, so if we look at the second one again, we see the negative absolute value of x minus 2 plus 3 is equal to 5. Solving by graphing, I'm going to graph both sides. So graphing y equals 5 is a horizontal line going through that value of 5. And then that absolute value, it has been reflected over the y-axis, it has been reflected over the x-axis. It's a vertical reflection. It's been shifted to the right 2 and up 3. So our new vertex is 2, 3. And I am reflecting down. So I'm opening downward. No vertical stretches or compressions or horizontal stretches or compressions, but it has been flipped. And so now I see this absolute value graph. So how many solutions does this have? None. No solutions, because that line doesn't even cross or intersect my absolute value graph. Okay, so here on the right hand side, we have those absolute value properties listed again. Those are in our 3.2 notes, so you should be familiar with those properties now. But then underneath, we have the steps for actually solving algebraically, and that's what's happening in our next example. We want to algebraically solve for x. And so there are 3 steps to solving an absolute value equation. The first and most important thing that we need to do is isolate the absolute value. So think of it like a variable. We need to isolate the variable. So we might have to subtract something, add something, divide by something, whatever. But that is our first step for solving. After we isolate that absolute value, we are going to set up 2 equations. Why 2 equations? Well, think about absolute value and the properties of it. Absolute value is representing a distance. So absolute value is always going to be positive. However, we know that the absolute value of -3, which is equal to 3, is also equal to the absolute value of 3. So these two things are the same. And so if we know what it's equal to, we don't know if we started with the -3 or if we started with the +3. So that's why we have 2 equations that need to be set up. And then the last thing is checking for extraneous solutions. This might be a new word for you, but extraneous or an extraneous solution just means that we did our mathematical process correct, but the answer that we got is not a valid solution to that problem. So what we need to do is we need to solve these equations, but when we get our answers, maybe it's two of them or one of them or whatever, we have to plug it back in to make sure it actually works. Now, this is a step that you should have always been doing. Anytime you're solving for a variable, you should always plug it back in to make sure you did your math correctly. But it's extremely important that we do it now because there is such a thing as having an extraneous solution. And we will see examples of that in just a little bit. So here we go. First thing, like I said, is to isolate the absolute value. So when I see example A, absolute value of x minus 3 is equal to 7, my absolute value is already isolated. So I can go straight to step 2, which is setting up two equations. So I know that what's inside the absolute value could either be the positive version or it could be the negative version. So everything is going to change signs. Everything is going to become quote unquote negative, meaning I'm going to apply that -1 to everything, changing the sign. This is how we create our two equations. So I drop the absolute value, leave it as it is for one, and then dropping the absolute value, making everything on the inside the opposite for the other. And so now I just solve. So over here on the left-hand side, I would get x is equaling 10. And then over here on the right-hand side, I get negative x equaling 4. So that means x is equal to -4. So it's looking like I have two answers. But third step says check for extraneous solutions. When I plug 10 in, 10 minus 3 is 7. The absolute value of 7 is 7. So that means it's a solution. When I plug in -4, -4 minus 3 is -7. The absolute value of -7 is 7. So that means this is also a solution. So we do have two solutions for that first problem. Going on to example B. Again, first step is isolating the absolute value. It's already done for us. But let's see what we have. We have the absolute value of 3x plus 1 equaling a -5. Let's pause and reflect there. Can an absolute value of anything ever equal a negative number? No, never. We said absolute values are always going to be greater than or equal to 0. 5 is not greater than or equal to 0. So therefore, there is no solution here. And if you needed to solve that graphically to get a visual, -5 is down here. 3x plus 1 would be something like this. Those two graphs do not intersect. Therefore, there is no solution. Okay? So be careful when you isolate that absolute value. If it's ever equal to a negative number, stop right there. That is not possible. All right, moving forward. The absolute value of 3x minus 6 minus 9 is equal to -3. Yes, I know that it's equal to a negative number, but I can't stop there because my absolute value is not isolated. I need to isolate my absolute value first. So to do that, I'm going to add 9 to both sides. So that will give me the absolute value of 3x minus 6 equaling 6. And now my problem has kind of gone away. I have an absolute value equaling a positive number, which is totally fine. I've isolated the absolute value. I go on to the next step, which is creating two equations, leaving it positive, and then taking the opposite from inside of the absolute value. And now I just solve. So on the right-hand side, when I solve, I'm getting 3x equaling 12, which means x is equal to 4. And then on the left-hand side, I get -3x equaling 0, so x is 0. I have to plug both of them back in to the original function, or at least the isolated absolute value function. And so plugging in 4, 3 times 4 is 12, 12 minus 6 is 6, absolute value of 6 is 6. 6 minus 9 is a -3, so that works. And then the same thing for 0. 3 times 0 is 0. 0 minus 6 is -6. Absolute value of -6 is 6. 6 minus 9 is -3. And so 0 also works as well. Going on to part D. So isolate absolute value, create two equations, solve, check for extraneous solutions. So here we go. 2x, the absolute value of 2x plus 12 is equal to 4x. My absolute value is already isolated, so I can jump straight into setting up two equations. So leaving it positive, and then taking what's on the inside of the absolute value and making it negative, turning it to the opposite. And now I solve. So 2x plus 12 equals 4x. I could subtract 2x, 12 equals 2x, divide by 2, 6 equals x. And then over here, I could add my 2x to get this. X is equal to negative 2. I have to plug them back in to check for extraneous solutions. Be careful now because I have an x on both sides. So when I go to plug in 6, that would be the absolute value of 2 times 6, which is 12. 12 plus 12 is 24. Does that equal 4 times 6, which is also 24? Yes, 24 does equal 24. But when I plug in negative 2, I'm going to get negative 4 plus 12, which is negative 8. Absolute value of negative 8 is 8, equals 4 times negative 2 is negative 8. Negative 8 does not equal positive 8. Therefore, this is not a solution. So this is one of the ones that just has one solution. So it's going through, it is going through the vertex of that absolute value graph. All right, moving on. Kind of a similar situation here. The absolute value of 3x minus 1 is equal to 2x minus 2. My absolute value is already isolated. So I jump in to create my two equations. So 3x minus 1 equals 2x minus 2. And then a negative 3x plus 1 equals 2x minus 2. Solving on the right-hand side, I could add my 1, subtract my 2x's, and I'd get x to be negative 1. And then on the right-hand side, solving for x, I could add my 3x over to get 5x equaling 3. So that means x is equal to 3/5. Okay? So then I plug both of those back in to check to see if they're extraneous or not. When I plug in negative 1 into both x's, that would give me absolute value of negative 3 minus 1 equals negative 2 minus 2. Well, that would be some number equaling the absolute value of something equaling a negative number. That's not going to work. Then I could also plug in the 3/5. So I'd have 3 times 3/5 minus 1 equaling 2 times 3/5 minus 2. So that would be something like so that would be 6/5 minus 10 over 5. So that would be a negative 4 over 5. And I can really stop right there because the absolute value of anything is never going to equal a negative number. So none of that worked. So that is not a solution either. And so this one just has no solutions. They were both extraneous. Okay, so in this next case, we have an absolute value equaling an absolute value. Whoa. So we have to take into consideration what we're doing. Our first step is isolating the absolute value. Well, technically, both of them are isolated, right? The second step says create your two equations. Well, when I was creating two equations, I just had one absolute value, and I was making the two equations from that one absolute value. Well, now if I have two absolute values and an absolute value produces two equations, then would you agree that this scenario will then have 4 different equations? 2 from this first one, 2 from the second one. But don't get too bogged down just yet. We're going to realize that all 4 of them are not necessary. So here we go. The first thing that I could do is I could take the positive of the first and equal it to the positive of the second. That's one thing. Let me just count out real quick. The second thing I could do is take the positive of the first and equal it to the negative of the second. Oops. Third thing I could do is take the negative of the first and the positive of the second. And the fourth thing I could do would be to take the negative of both. Those are my four options. This was positive, 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 negative, negative, positive, negative, negative. Those are the only four things that can happen. Well, out of these four things, two of them are repeating themselves. This first and this last are the exact same thing. It's just one of them has been multiplied by a -1. So why do this one when I can do this one? Okay. And then out of the middles, these are also the same exact things because I can just multiply one of them by a -1 and I get the other. So I can either keep 2 or 3. It doesn't matter. So let's say I keep 3 just for the heck of it. All right. So I'm going to erase all of this and I'm only going to keep the 2 that I want. Okay. So here are my two equations. And so just keep in mind now, when you have two absolute values equaling each other, you don't have to do 4 scenarios. You can do one where it's positive, positive, and then you can do one where you're just changing either one. You can either change the first one to be a negative and keep the second one positive, or vice versa. You don't have to do all 4. Okay, so that's good news for you guys. And so then I just solve like normal. So I can subtract my x, subtract my 1. I would get 7 equals x. Okay. And then over here, I could, let's say I subtract the 2x, add that. That would be -3x equaling 9. So that means x is going to be -3. I still need to plug in both of these values of x to check to see if they're extraneous. I have to plug them into both locations of x. When I plug in 7, absolute value of 7 plus 8 is going to be 15 equals 2 times 7 is 14. 14 plus 1 is 15. Absolute value of 15 is 15. So 7 is the solution. Then I'm going to check my -3. -3 plus 8 is 5. Absolute value of 5 is 5. 2 times -3 is -6. -6 plus 1 is -5. Absolute value of -5 is 5. 5 equals 5. So this is also a solution. Okay, don't worry, we're going to do that again. Here we go. Absolute value equals absolute value. So, here we go. So step 1, isolate your absolute value. That's already done. Second step, set up your two equations. So remember for this one, we actually are going to keep it as two equations. So I'm going to keep my positive, positive. And then let's say this time I'll do the positive and then the negative. Remember, it doesn't matter if you do the -x minus 5 equaling x plus 11 or the x plus 5 equaling -x minus 11. So on the left-hand side, solving for x, I end up getting something like 0 equaling 6. Well, that's not a true statement. Therefore, there's no solution for this part. Okay? That doesn't mean there's no solution for the entire equation though. So don't get ahead of yourself. You still need to check the other side. Okay, on the other side, I end up getting something like 2x equaling -16. So that means x is going to be -8. I need to plug in that value to see if it actually works. And so if I plug in -8 for both values of x, I get -8 plus 5, which is -3. Absolute value of -3 is 3. And then -8 plus 11 is 3. Absolute value of 3 is 3. So 3 equals 3. Bless you. That was my dog just came in. So this is, in fact, a solution to this equation. And so maybe you're thinking, well, how do I have just one solution when I have two absolute values? Think about that graphically, guys. I could have something like x plus 5 is just going to be a normal one shifted to the left 5. And then x plus 11 has been shifted to the left 11. So there is my one solution. Okay, so when you have two absolute values, one solution, two solutions. You see all these possibilities that could be happening. Could you have no solutions for an absolute value and an absolute value? What if you have something like this? That would be no solutions. So you can still have one solution, two solutions, or no solution. And this was one that had one solution. Earlier, that was one that had two solutions. Okay. So let's see what's happening in H. Let's go here. 5x plus 12, or absolute value of 5x plus 12, is equal to 2 times the absolute value of 4x minus 1. Now, my absolute values are isolated. The one on the left is isolated. The one on the right is not isolated. But if I isolate the one on the right, then the one on the left won't be isolated. So I go between this like battle of which one do I isolate? It doesn't matter. Okay, as long as one of them is isolated, you're good to go. Okay, you're never going to get both of them isolated if there's something else there. So I can jump straight into creating my two equations. So I'm going to do my positive, and then I'll do negative positive. And remember, you could also make it positive, negative. It doesn't matter. Okay, be careful. Absolute values are grouping symbols, so when we drop them, we have to replace them with parentheses in this particular case because there is a 2 in front. All right, so I solve. So first thing I want to do here is distribute that 2. So that's going to give me 8x minus 2, and then I can solve, and that's going to get me something like maybe a negative 3x if I subtract the 8x. Subtract that, that'll give me negative 14. So this is going to give me a positive 14 over 3. Yes, I do need to plug that back in to check. And then over here, negative 5x minus 12 is equal to 8x minus 2. Solving for that, let's say I get the 13x and then equaling a negative 10. So then x is going to be a negative 10 over 13. Yes, you need to plug that in. Okay, I'm sorry. Plug in the value of x here and here for the 14 thirds and the negative 10. 14 thirds and the negative 10 over 13. And you are going to see that they are both, in fact, solutions. Okay, this is a part where you could pause the video and double check that. Okay, if you need to take out a calculator real quick and do that, that's fine, even though you shouldn't need a calculator for that. Okay, you're in honors algebra 2. Come on, suck it up. All right, just want to show you that process though. So we've done some where absolute value is already isolated, equal to a number. We've done some where we just need to isolate that absolute value. It's equal to a number. It's good to go. We've had some where we had x's on both sides. We've had some where there's absolute values on both sides. And so now, whoa, what do we see there? We see an absolute value within another absolute value. Yikesola. Don't freak out. Take it piece by piece. We can do this, all right? So what we're going to do is we think about working from the outside in. So I'm going to kind of color code here. So let's use yellow for my outside absolute values. And let's kind of ignore those inner absolute values right now, okay? I technically have the yellow absolute value isolated. So I'm going to start my process of solving and I'm going to create two equations. Okay, so my two equations are going to be the positive and the negative. So negative absolute value of 2x plus 5 plus 3 equals 10. Nothing has changed of what we've been doing. So imagine like you're kind of replacing this with an x. X minus 3 equals 10. Negative x plus 3 equals 10, okay? Or replace it with an a or a b or whatever other variable you want to think about, okay? I didn't do anything different. So now that I have these two equations, then I can solve them as an absolute value function. So now I am looking at those inner absolute values here. And so my goal in solving these equations is isolating that absolute value. So over here, to isolate that absolute value, I'm going to add my 3 over. So I have the absolute value of 2x plus 5 equaling 13. Oh, what can I do here? I can create two equations, a positive and a negative. go ahead and solve. Okay, so for this one, let me change colors one more time. So for this one, I would get 2x equaling, that's 8, so that means x is 4. Over here, I would add my 5. I'd get 2x equaling 18, so x is equal to negative 9. Okay, I can plug those both back in right now if I want, or I can go to this second equation over here and isolate that absolute value. So let's think about, let me move this over a little bit. Let's think about how we would isolate this absolute value. I would have to subtract my 3, and I would then get the negative absolute value of 2x plus 5 equaling 7. Then I would have to divide or multiply by negative 1. And when I do that, I get the absolute value of 2x plus 5 equaling negative 7. Is this possible? Is this a true statement? No. An absolute value is never going to equal a negative number. So this whole situation here doesn't even need to be split further into two equations because this is not a true statement. Hallelujah, praise the Lord. If it would have been, we would have broken it up again into two equations. 2x plus 5 is equal to negative 7. Negative 2x minus 5 equals negative 7. We're not going to do that because we know that it's not true. It's not going to be right. But, okay, so what I do need to do now is check these values of x. I need to plug them back in to my x. So working, we would have 2 times 4, which is 8. 8 plus 5 is 13. So the absolute value of 13, minus 3 is 10. Well, the absolute value of 13 is 13. 13 minus 3 is 10. Absolute value of 10 is 10. So this is definitely a solution. And then we would also have the negative 9. Well, 2 times negative 9 is negative 18. The absolute value of negative 18 is 18. 18 minus 3 is, wait, I did that wrong. Let's try this one more time. I went too fast. All right. Okay. Absolute value. 2 times negative 9 plus 5. Oh, that's what I was missing. Minus 3 equals 10. Okay. 2 times negative 9 is negative 18. Negative 18 plus 5 is, negative 18 plus 5 is negative 13. The absolute value of negative 13 minus 3. Well, the absolute value of negative 13 is 13. 13 minus 3 is 10. 10 does equal 10. So yes, this also works. Sorry, I went through that kind of fast. And then let's try something else. It's not an absolute value within an absolute value, but it's an absolute value divided by an absolute value. So remember the property we learned says when I'm dividing two things within an absolute value, I can rewrite that as the absolute value of one divided by the absolute value of the other. And that's going to equal 5. My first step is isolating the absolute value. So to get the absolute value of x minus 1 by itself, I'm going to multiply both sides by my denominator. So I'm going to end up getting the absolute value of x plus 1 equals 5 times the absolute value of 3 minus x. So now one of my absolute values is isolated, and this is exactly like what we did earlier in example like H, right above it. Okay, so then I could do my positive, and then I could do my negative, positive, or my positive, negative. And then I solve. So over here, I'm getting x plus 1 equals 15 minus 5x. Solving, I would get 6x equaling 14. So then that would be 14 over 6, which reduces to 7 over 3. And then over here, I get negative x minus 1 equals 15 minus 5x. Then that would get me something like 4x equals 16, which means x is 4. And so plugging both of those in to the values of x, here and here, or here and here, this is going to be a solution, and this is going to be a solution. Again, you can pause the video and double check that. Use your math skills. Okay. And then lastly, for solving equations, we have a scenario where we could have, where we have an absolute value plus an absolute value equaling a number. So for this case, we want to think about the different situations. This is not the same thing as an absolute value within an absolute value, or an absolute value equaling an absolute value, but we need to think about these four scenarios. We could have a positive plus a positive. We could have a negative plus a negative. We could have a positive plus a negative, and then a negative plus a positive. Okay? In these situations, none of these are the same thing. Okay? None of them are the same thing. So we have to do all four. So if I do positive, positive, that would be 3x minus 2 plus x plus 2 equals 6. Okay? Let me also, I'm going to change colors when I do these. So I'll do the first one in this pink. Okay? So I solve. I get 4x equaling 6, which means x is 3/2. Then we said we could also do positive, negative. So that would be 3x minus 2 plus negative x minus 2 equals 6. So that would be 2x minus 4 equals 6, which means 2x equals 10, which, means x is 5. And then I could have negative plus positive, which is going to be negative 3x plus 2 plus x plus 2 equals 6, which means that that would be a negative 2x, negative 2x plus 4 equals 6. So negative 2x equals 2, which means x is negative 1. And then we could also have, I'm running out of space. We could also have negative and negative. So that would be negative 3x plus 2, technically plus a negative x minus 2 equaling 6. So that would be negative 4x equaling 6. So that would be x is equal to negative 3/2. Okay, I need to plug in each of these values of x to see which ones are actually solutions. Okay, and when I do that, I end up getting x is 3/2 and x is negative 1. This was not a solution, and that was not a solution. Okay. So take your time and actually plug in those values to see if they actually work or not. And then, of course, lastly, we have some applications. We have some word problems. Okay. So it says the average temperature in Texas in July is 96 degrees. And I would beg to differ. I think it'd be a little bit warmer than that, but maybe not. Maybe it's only 96 degrees. And so it says the actual temperature may be 10 degrees cooler or 10 degrees warmer. Write an absolute value equation and solve for the maximum and minimum July temperatures based on this information. So, the difference between the actual temperature and the average is 10 degrees, whether it's 10 degrees warmer or 10 degrees cooler. So, how do we write that as an absolute value equation? Think about what I'm saying here. The difference in math, that means subtract. The difference between the actual temperature, which we don't know, so we're calling that some value, maybe it's x. The difference between the actual temperature and the average temperature is a window of 10 degrees. It could either be 10 degrees cooler or it could be 10 degrees warmer. AKA, it could be positive 10, 10 degrees warmer, or it could be negative 10, 10 degrees cooler. So the difference between the actual temperature and the average is going to have that difference of 10 degrees in the positive or 10 degrees in the negative. So think about this realistically, guys. What is an average temperature what is an actual temperature in July? Maybe it's 100 degrees. If I plug in 100, does that make sense? 100 minus 96, absolute value, that would be 4. Does 4 equal 10? No, but we're saying it could be up to 10 degrees warmer or 10 degrees cooler. So maybe like 106, aka, right? So if we solve this algebraically, I already have my absolute value isolated. I would create two equations. And so then this would give me the x is 106. And then this would give me negative x is equal to 86, negative 86, which means x is equal to 86. Those are obviously the max and the min of the actual temperatures in July in Texas, which definitely makes sense. Okay. And then it says, for example, whatever this is, the last example, Jim bounces Dwight a basketball. Jim is holding the ball at a height of 4 feet when he passes it. It bounces 3 feet away from him, aka Jim. Dwight is standing 2 feet from where the ball bounced. Create an absolute value graph to model the situation. How high did the ball bounce for Dwight to catch it? So, yes, these are office references, Jim and Dwight. So think about this physically happening, right? You have this dude, Jim. Okay, he's really tall and skinny. You have Jim, and he's holding a basketball. There's our basketball. Obviously, it's not going to be at the height of his head. It's going to be kind of around his hip area. And that's what it's saying. It says he's holding it at a height of 4 feet. So the ball is actually 4 feet off the ground. So this is 4 feet. When he throws the ball down to the ground, it bounces and then it comes back up, and that's where Dwight is going to catch it. Okay? Dwight's kind of like me, and then Jim's kind of like, eh. Hold on, let me fix that. And then Dwight's like, meh. Okay. Jim's a lot taller than Dwight. I don't know why I did that. But anyways, so let's also fill in some other information. He's holding it at a height of 4 feet. So here's 4 feet. It says he bounces it 3 feet away from him. This is where the ball bounces. And then it says Dwight is standing 2 feet from where the ball bounced. How far up, how high does he catch it? Okay. How high did the ball bounce for Dwight to catch it? So think of this as a coordinate plane. This, let's say this is our 0, 0. Then this point here would be at 0, 4. This point here would be at 3, 0. This point here would be at 5, 0, because 3 plus 2 is 5. And then we have to figure out this point right here. We know that would be 5, something. We don't know. And so now we can see this V shape formulating, right? And so that is our absolute value graph. And so if we think about this on the coordinate plane, I know the vertex of this absolute value is 3, 0. That means I shifted to the right 3 units. You know what that looks like. That's x minus 3. We also know that there's been some kind of vertical stretch or compression, right? Because I know my height. I know this slope is a rise of 3 and a run of 4. Okay? I'm sorry, a rise of 4 and a run of 3. I'm going up 4 units and I'm running 3 units. So that means that slope is 4/3. Okay? I'm trying to figure out this value of y. So if this is my function, then I can solve that for y by plugging in the value of x that I know. Okay? f of x is equal to 4/3 times 5 minus 3. Well, 5 minus 3 is 2. Absolute value of 2 is 2. 4/3 times 2 is 8/3. But realistically, what does that translate into? 2 and 2 2/3 of a foot. That makes more sense. And so that's where Dwight catches the ball. How high did the ball bounce for Dwight to catch it? 2 2/3 feet. The end. Okay, bye.